Hydrogen vehicles. How do they work? Are they safe? When can we expect to be driving one? And most importantly, how can they help us reduce our carbon footprint? We're here today with Vicky Au from the CSIRO. So Vicky, what is your vision for the future of road transport in Australia?
I think what we'd really like to see in the next 5 years or so is really an increase in a movement away from fossil fuel dependent road vehicles. That will really help towards decarbonisation for Australia generally. Road transport also makes up a large part of our freight and logistics here in Australia. We're quite heavily reliant on road transport, and to see that shift to low emission or zero emission vehicles would be fantastic.
So in the most simplistic form, what we do is we take hydrogen into the vehicle in the form of gaseous or liquid hydrogen, and then it's passed through what's called a hydrogen fuel cell. And essentially what happens is the hydrogen will go in. Also, we take air into this as well. And the hydrogen tries to combine with the air within the fuel cell. And when it does this, it releases electric power, which we capture, and we use that in the drivetrain of our vehicles. And then the only output from this is heat and water out of the exhaust pipe.
Okay, so no carbon emissions.
There is no carbon emissions locally as these vehicles operate. So you can produce hydrogen in many different forms. The ideal form to have completely zero emission free transport in this type of scenario is to generate the hydrogen from renewables, solar, wind and so on. It is a zero emission energy transport scenario that we can present. It is really exciting technology. There's a huge amount of development which is going into it, and a really exciting space to be in at the moment. The key thing to note, let's talk about the similarity. They are both electric vehicles.
Right.
So they both use an electric motor to turn the wheels. The biggest difference is that in a battery electric vehicle, we store the energy in a battery. And in a hydrogen fuel cell vehicle, the energy is stored in the form of hydrogen. So these have in the vicinity of 300 kilowatt hours of battery capacity on them. So it takes significant time to charge up. And what that means is we have a lot of electrical capacity required to feed these chargers to charge these vehicles quickly. So we really want to bring these vehicles back online as quickly as possible so they can keep making money. On the flip side of that, if we talk about hydrogen vehicles have a lot of analogy and similarity to what we see with refueling a fossil fuel vehicle. You literally drive into a station, you hook up to a bowser, whether it's a gaseous bowser or potentially a liquid hydrogen bowser, and you can fill up your vehicle with hydrogen and pay the person, take off again and keep the vehicle running. So the recovery time with a hydrogen vehicle is significantly less than a battery electric vehicle with current technology. When we look at this scenario, we really look at it in the context of what are the goals that we are trying to achieve. So for us, and we're in heavy transport in the transport industries, how do we transport the goods that we need to for our society? With the hydrogen side, it's a different fuel that comes into it. And yes, there are some different requirements around refueling infrastructure and also considerations around the road environment and so on. But essentially, we're moving the goods still in the most efficient form possible. However, when we are using hydrogen, especially with a fuel cell, there's a zero tailpipe emission. So it has a huge amount of attraction and also alignment to our future emission goals that we're talking about.
Today in Australia, the Toyota Mirai and the Hyundai Nexo, both fuel cell electric vehicles in the passenger segment, are achieving ranges between 650 and 660 kilometres on a full tank of hydrogen.
Range is something which is really important, as you'd imagine, for a commercial vehicle in the space that we're in. And from a battery electric perspective, it's a very easy equation to understand. If you want a battery electric vehicle to go further, you put more batteries in. The challenge with that is that as you put more batteries on, the vehicle gets heavier. So you carry less of what's so important in our industry, it's called payload. Now with a hydrogen vehicle, because of the way it actually operates and it utilizes the power, their mass is very, very consistent for a certain range. Now, similar scenario, if you do want to go further, yes, you would put more tanks on there. That being said, the current testing that we are doing in Germany at the moment with some of our products, we can accomplish a range of about 1,000 kilometers with what we'd term as a 40-ton combination vehicle. Payload, important number, 25 tonnes. And we do that with surprisingly 80 kilograms of liquid hydrogen.
A key benefit of hydrogen is the quick refueling time. It can take approximately 5 minutes to fill an FCEV, 15 minutes to fill a bus, and 30 minutes to fill a large truck.
There are probably 3 key challenges that we could look at for the transition to hydrogen road vehicles. The first is that there are fewer than 10 refueling stations here in Australia at the moment. The second one is, I'd say, product range and variety. You don't see the number that you do for battery electric, but certainly there are many overseas manufacturers that do have it in their product range. And the last one is probably cost. It currently costs quite a bit to bring some of the hydrogen vehicles over here. The hydrogen trucks are quite expensive. Prices have come down a lot with increased demand. We'd really love to see that also happening here in Australia.
So next time you see a truck or a bus, take a look at the tailpipe. Is it only water vapour coming out? If so, the future's already in your neighbourhood.